For today's lesson, we are looking at the learning targets for solving logarithmic equations and solving exponential equations. As a reminder, please remember to write down any questions you have through the lesson so that you can either ask your teacher when you come back to class or either to use as study questions later on. From last time, you learned about log base 10. As a reminder, log base 10 is also called the common law, and the base is not written. So it's important for today that you remember that if you see log 7 or log of 7, it means that you have a base of 10. So looking at the first example, we have that log of x equals 3. So again, remember, the base is not written, but it's going to be a 10 here. So there are two ways, if you guys remember from last time, on how to solve this. One is to exponentiate. So we're going to take the 10, I'm going to write it this way, and what happens when you have 10 raised to log base 10 of x, these guys are gone, and all we have left is x. And on the other side, we're going to have 10. It's kind of written awkwardly, but it's 10 to the third power. Now, the nice thing about powers of 10 is that this exponent here basically tells you how many zeros you have. So we're going to have 1,000 as our answer. Now, the other way of looking at this is actually, I'm going to rewrite the problem, is to rewrite it. And again, remembering that rewriting it, you can think of this as, well, I need the base. Logs are equal to exponents, so that means 3 is the exponent, and then it's going to equal what we have right here, which is the input of the logarithm. So it equals x. Either way, you're still going to get 1,000 for your answer. All right, looking at example 2. First thing is you have to isolate the logarithm. So I'm going to divide by 5 to get the logarithm by itself. So we have log of 20x is equal to 2. And again, we can look at this in two different ways for solving. I can either try to exponentiate or we can rewrite it. I am going to rewrite it. So it's important to remember what is the base of this logarithm. It's 10. So it's 10, logs are equal to exponents, so the exponent is 2, and it's going to equal the 20x. Okay, I'm going to rewrite it up here for more room. So 10 squared is 100, so 100 is equal to 20x. And then clearly from here we're going to divide both sides by 5. Sorry, we're going to divide both sides by 20. The answer is 5. All right, moving along. Properties of logarithms. So we're going to learn more about properties of logarithms after the SOL test, but you actually need this property in order to be doing some of the solving. So if you have log base b of a to the x, a nice little property allows you to take this exponent and put it in front. So this is going to equal x times log base b of a. So we're going to be using this property when we solve some of the exponential equations. So just to practice this, we're going to rewrite these two logarithms with using this property. So this first one, take this x, place it in front. So this is going to be x times log base 3 of 5. Looking at the second example, do you remember what the base is here? Hopefully you guys remember that it's a 10. But I'm going to take the exponent and bring it out in front. So we have x times log of 24. Looking at this next learning target, we're going to be solving exponential equations. Now for these particular equations, we're going to be solving them such that they cannot be rewritten with the same base. So to solve them, we're going to take the log of both sides. So looking at the first example, when it says take the log of both sides, I'm just going to say log and log. I'm going to rewrite it because I actually just need to see it cleanly written. So we have log of 4 to the x is equal log of 10. So using this property that we just came up with, I'm going to take this exponent here and bring it out in front. So we now have x times log of 4 is equal to log of 10. Now the whole point of solving is to get the variable by itself. So that means we want to get rid of this log of 4. So to do so, we're going to divide both sides by log of 4. It's important to remember that a logarithm is a function, so the word log always should have something after it. So at this point, this can cancel out. So we have x is equal to log of 10 over log of 4. And yes, this actually is your answer. Don't fret, this is what it is, and we can move on from there. All right, so let's take a look at the next page. Not it. There we go. Next page. All right, so at this point, we have a similar situation, but we need to get the power by itself. So the first thing I'm going to do is add the 5. So now we have 6 times 3 to the x is equal to 30. And again, I need to get the power by itself, so I'm going to divide both sides by 6. So now I have 3 to the x equals 5. Clearly, I cannot rewrite 5 as a power of 3 or 3 as a power of 5. So this is a time when we're going to take the log of both sides. So I'm going to write log and log. And I'm now going to rewrite it up here for more room. So we have log of 3 to the x is equal to log of 5. And do you guys remember from the previous examples what to do next? Hopefully everyone's like, yes. We're going to take this exponent and place it in front. So we have x times log of 3 is equal to log of 5. And then again, we want to get the x by itself, so we're going to divide both sides by log of 3. That cancels out. The x is now successfully by itself. So our final answer is going to be log of 5 over the log of 3. You're going to continue watching the next video to get the remainder of the lesson.